Okay, on to our talk about, or on to topic 7.9, which is phylogeny. So the first thing we need to really define here is phylogenetic tree. A phylogenetic tree is simply I like to think of it as a hypothesis, but it is a diagram to represent evolutionary relatedness. Not unlike a family tree, obviously with species rather than individuals, but it is very similar in the fact that you are looking at the relatedness between different species that you're studying. In this case, to the left, A, B, C, and D, and E. Okay, it's important to note that a phylogenetic tree is simply a hypothesis. These are not set in stone. They are prone to changing depending on new data. Maybe you do a molecular analysis of DNA or protein structure, and you see that actually this is not correct, right? So these are not necessarily always based on the same thing, meaning that they're not always quote unquote correct. This is a hypothesis. A monophyletic group or a clade is simply uh, all of the descendants of a common ancestor. So what do I mean by that? Well, if we look on here, we can say that this right here, A and B, these are a clade. They are all the descendants of this node right here, this point, which is a common ancestor. You could also say that A, B, C, and D are also a clade because they all have a common ancestor right here. So that is a clade or monophyletic group. All of the descendants of a common ancestor. Okay, so that is a clade. You can, C and D also would be a clade in this scenario, right? Because they have a common ancestry. The key point is that must include all of the descendants that you're studying, right? The outgroup is the least related. Species. Species on the tree. I.e., which species, is pretty much equally related to everything else on here because it shares a common ancestor with everything else on here. In this case, that would be E. Usually it is the one that branches the soonest from this root over here. So in this case, the outgroup would be E, right? Because it is the least related. It is the most different from everything else. Now, important to note, let's take a look at this. If I was to ask you, is organism C more closely related to D or to A? Or let's say I'll say, is C more closely related to A or D? Well, you can look at for common ancestors. Common ancestors of C and D, if you follow these lines back, are going to end up right here, right? Common ancestor for A C, follow this all the way back, it's going to be here, right? So if you look back in time, right, the ancestors of these organisms are way back in time. Present day species are all here, and this is time passing. The one that diverged more recently, or has the most recent parent species, for lack of a better word, would be C and D over here. So C and D are definitely more closely related than C and A or C and B, either of these. So that's just an interesting thing to look at. We've already had some practice with this in class, so you should be fairly good at showing relatedness. Let's look at another one just to be sure. I have a large cladogram here, or phylogenetic tree. It's showing these traits, right? Each of these marks shows where traits were acquired. So in other words, you have species, pre-vertebrate species, right? Of course, there's a branch over here that could show invertebrates, but right here, species acquired a vertebrae. This means that they have a spine, right? Jawless fish, cartilaginous fish, bony fish, all of these have vertebrae, right? At this branch point, everything above here has jaws, right? Everything above here has jaws. Likewise, bony skeleton. Everything from this point up has a bony skeleton, right? Has a bony skeleton. This is just an interesting way of seeing how how traits are acquired on one of these trees, or show where they are acquired from an evolutionary perspective. Okay, but let's look at relatedness again. If I was to ask you, let me see here. Is a lizard more closely related to a bird or to a turtle? Let's go ahead. I'm going to ask you to pause right here and tell me whether a lizard is more closely related to a bird or a turtle. Okay, you should be back. All right, let's follow it down. Lizards and birds, where do they share a common ancestor? Let's follow it back in time. Follow the birds back in time, and you end up at this point here, right? So the ancestor of lizards and birds is right here, right? Let's look at the ancestor of lizards and turtles. Well, let's follow this line down. We're going to go further down so we can meet up with the turtle ancestor right here. This is the ancestor of lizards and turtles, right? So I think you could definitively say here, according to this phylogenetic tree, at least keeping in mind its hypothesis, that lizards are more closely related to birds than they are to turtles, because lizards and birds' common ancestor diverged more recently. We can even, put numbers on this if we want to. We could say, 10 million years ago. This would be, a longer time ago. We'll say 20 million years ago, just to put a number to it. That means that they had more recent, relatives. Obviously, these numbers are way off, but they have more recent relatives. The lizards and birds have a more recent common ancestor, right, than turtles and lizards, which diverged, much sooner than lizards and birds did. That's all for the basics of phylogeny. I think if you can do these, you should add all of the phylogenetic tree construction, which we're going to do in class. You should be good on phylogeny. If you have any questions, let me know.